How you doing, eighth graders? Mr. Koenig here. I'm going to talk to you today about 523 resource sheet. And in particular, we're going to work through the second page, which is actually 543, changing populations. It's going to be two different schools, and they're going to be one growing, one shrinking. And our goal is going to be to try to find out when the schools have the same population or amount of students. You're going to do a problem that's very similar to this. It's actually going to be on page 1. So make sure you pay attention to this video. It's going to help you with the other problem today. All right, so here we go. Post Falls High School in Idaho has 1,160 students and is growing by 22 students per year. Richmond High School in Indiana has 1,900 students and is shrinking by 15 students per year. How many years will it take for the schools to have the same number of students? And how many students will be enrolled in each school at this time? All right, so the first thing we got to do is make rules for each of the schools. It helps to know what they're growing or shrinking by. It also helps to know their starting point. Remember, when you're making these rules, the second blank is actually always the starting point, or like year 0. So for Post Falls, we got to figure out what they started with. It's 1,160. So that's going to go there. And then we have growth of 22 students per year. The growth always goes in front of the X as the coefficient. So there's the rule for Post Falls. And then the same kind of logic applies to Richmond. Richmond's starting point, or year 0, was 1,900 students. And this one, you have to be careful because it's actually shrinking. So that's a negative, right? If you're losing money or losing students, that's negative. A negative 15 students per year shrinking. All right, so there are the rules. Now, the next, one of the ways that you can solve a system of equations is graphically. Okay, so you're going to be using Desmos to actually do that. I did some of this ahead of time so you don't have to see like me setting up everything. So basically, you click Desmos. It will take you to obviously the Desmos graphing calculator. When I click over there, you'll notice that I have already sort of completed this. So I hit plus up here to add these expressions. And basically all I did was put in my equations from the previous page, from the worksheet that I already had. Okay. So when you put them in, you'll notice that there's a point of intersection where they equal each other. And that point is 1,600. What that's telling me is that after 20 years, each school will have 1,600 students. Okay, so I need to take a screenshot of this. Copy it over and paste it into the assignment. And there we go. I can see both rules. I can see the point of intersection. Okay. So I'm just going to skip down to the table, and then we'll do algebraically last. All right. So you can also solve this system with a table. You notice this wasn't convenient, really. This was not the best way to solve this system. So what I did was set up a table for high schools, Post Falls and Richmond. And I just started, like Post Falls, year 0. Remember, they started with 1,160 students, and then they said they were adding 22 every year. So this took me a while. I had to go 1,160 plus 22 plus 22 plus 22 plus 22. I had to keep adding 22 every year until I finally got to year 20 for Post Falls, and they had 1,600 students. And then you'll see Richmond, same thing. Year 20 had 1,600 students. For Richmond, I had to start at 1,900, then subtract 15 every year. So it was minus 15, minus 15, minus 15. So that's why I did this ahead of time, because I was like, you probably don't want to watch me, for 10 minutes do that. But anyway, we do know now that two of our ways to solve the graph and the table have confirmed that in year 20, both schools have 1,600 students. Let's just do the final way, which is algebraically. And see if that also confirms. So algebraically, what you're going to do is actually drop the y's. So you'll notice Post Falls says y equals 22x plus 1160 and y equals negative 15x plus 1900 for Richmond. Now, because they both equal y, that means these chunks 22x plus 1160 and negative 15x plus 1900 are actually equal to each other as well. So we're going to drop the y's, and we're going to set those two chunks equal to each other. So we're going to say negative 15x plus 1900 equals 22x plus 1160. All right, so remember our goal when we are solving equations is to get variables by themselves on one side. You can start by, with the x's, or you can start with the lone numbers. It doesn't matter. So I just see negative 15x. I'm going to get rid of that with a zero pair. And remember, we want that to be on both sides of the equation. So here, drops out, right? Negative 15x plus 15x is going to be 0. So we're going to be left with 1900 equals, okay, now you will have to add 22x plus 15x, you get 37x plus 1160. That was good because now we have x is only on one side. That's nice. And now we need to get that 1160 out of the right side. So again, another zero pair minus 1160 because it's the opposite. So you got to do minus 1160 on both sides. Do it over here first. Okay, now you're going to see the zero pair that occurs on the right side. And then you just need to do 1900 minus 1160 on the other side, on the left. And you are going to get 740 equals 37x. Last step, we're down to a one-step equation. Divide by the coefficient. So you got to do 740. 37 divide 37 on one side, which do 1x, and then 740 divide 37 on the side. Okay, so do that, and we get 20 equals x. Okay, and it was, again, that was divide by 37. You always divide by the coefficient on both sides. Now that is really part of the answer. I'll go back and clean this up and add some, stuff later, but that's part of your answer. Now you need to find out also, so that's years, like 20 years. We knew that, but we also need to find out how many students that was. So once you get x, there's actually one more step. You go back to either of the original equations and then insert 20 for x. So I'll just go back to the y equals 22x plus 1160. We'll use that one. It doesn't matter which one you use, whatever one you're more comfortable with. I'm using y equals 22x plus 1160 because there's no negative numbers. So that's why I choose that one. So we go and we say y equals 22, not x anymore. We think it's 20 plus 1160. Okay, so then we do a little bit of math. First off, remember when a number and two numbers are smashed together, like 22 and 20, that's multiply. Okay, so when you do that, you get y, my face out of here, equals 440 plus 1160. And when you do that, 440 plus 1160, you get y equals 1600. Okay, so there is the math for the algebraic solution. Notice x equals 20, that's 20 years, and y equals 1,600 students, 1,600 students. Okay, final thing you got to fill out. Schools will have the same population of students after 20 years. The number of students in each school will be 1,600 students. Okay, now the algebraic part is probably going to be the most difficult. It is for every year students we've done this with has been the most difficult, but we will get better and easier once you practice. Okay, go back and rewatch the video if you need to. Remember the graphing part, you just put the rules in Desmos, and then the table you just have to, it might take a little work, but it's basically repeated addition or subtraction or whatever based on the growth. So good luck on this. Remember, you're going to be doing the chubby bunny problem is up top here, and your teachers will preview that with you at this point. All right. Good luck on this assignment. See you next time.